Okay, it looks like we're live, so welcome back. Today I'm going to be continuing to work on Kano script. Alright, so let's see. The last time I worked on it was yesterday, and I did not stream it because I was having some issues with my power and such. I didn't want to have to deal with that. So you might have missed something if you don't follow the YouTube. So I can basically recap what has been done. So we implemented order of operations in the expressions, right? So now this will evaluate properly. So we'll evaluate 3 times 2, right? So that's 6. We'll add 2. So that's 8 plus 5. So it's going to evaluate to 13. So if I build it, and I compile it, and then I have to assemble it, and I'm going to have all these be automatically performed by the compiler at some point, but not yet. So kano.tasm, kano.10, and we echo that, 13. So it works, and I can just go over quickly how it works. So basically, parse expression. So let's see. Here is the main thing. So we call parse expression, right? Whenever we have an expression to parse, and it will call this sub function, right? So it has tokens, parse primary, which will go over what that does, and then this is the precedence level. So actually, this can be track 1, because that's really what it's supposed to be. Okay. And here is the parse primary. So you can see it takes a primary. So basically it supports integers, but soon we'll be able to implement identifiers. That's hopefully today, perhaps. It's like variables and such. So basically we take the token and then we make sure it's an integer, and then we allocate a new expression of type integer, and then yeah. So that's basically how that works. We return the expression. So that's going to do that. So say we have 5 plus 3, right? It will parse primary and it will return this as the left-hand side. And then we basically just go through it and we look at the next token based on the operator type. If it's greater than the precedence, then we'll keep going, basically, and then we keep doing that for each of them, and then we end up with the left-hand side and the right-hand side. And we call it recursively and such. But at the end, it builds out the syntax tree, from which we can compile it. So that's basically how it works. It's not too complicated. There is the Wikipedia page for precedent. Yeah, this one. So I will probably, if I remember, leave that in the description on the YouTube video, and it's in the Twitch chat right now. It has like the pseudocode and stuff, so it's pretty useful. It's basically implemented from that. Okay, so today I would like to implement variables, right? So let me just make this x is 0. So I was thinking for the syntax. This isn't final, but I think what I would like is something like this. So x colon data type equals value, right? That's basically the structure. Yeah, so something like that. And then, so it is going to be statically typed, but I would like to be able to infer the type in a similar way that Go does. I like Go quite a bit. So it'd be something like this, right? Because you can infer the data type quite easily on this. But that will be syntactic sugar once most of the features are implemented, you know? But this is like the primary way to do it, and you can specify the exact type and things like that. And I think that is acceptable. So there's no like initial keywords like let or anything like that. So it's just you start with the identifier, and then depending on the next token, you'll do different stuff. So say it's x equals 15, that's gonna change the value, right? Or if you are declaring a function, which I'm not doing that today, but this is what I'm planning on it to look like. Declare a function like this. So it's identifier and then open, and that's how you know it's a function, right? And then all the arguments in there, and then the return data type, right? Like that. And then I'm not sure if I'll have like start or if we'll be able to just figure it out from that, basically. But then, you know, end. We'll have an end block. And this is what a function will look like, basically. Yeah, so I think that would be pretty cool. But this is what I'm going to work on today. So there might be variable reassignment. It depends on how it goes. But this is what we need to parse. So we need to parse a colon, identifier, and then we need the type, equal sign, and then we already have the expressions. So those are the things that we need to parse right now. So let's go ahead and do that. So first of all, we need to add new tokens. So I think right here we'll have tt ident, and then tt equals. Yeah, that kind of goes with those. Tt, what was the other one? Colon. Very fine. Colon. And then was there another one? Yeah, and then tt type, right? So it's token type. And that will probably go. I'll put it down here. Yeah, makes sense. So this int is for an actual int. It should probably be called int literal. That would probably make more sense. But yeah, so we'll have type, and then we'll have the subtypes, right? So basically, I need to add those here as well. And now I made this very confusing. Let's try to add that. So after exit, we have identifier, and then we have equal. Okay, equal colon, graphic colon. Maybe when that happens. Yeah, so colon is like that, not a semicolon. So we don't have any semicolons at the end of the line, and I don't think we'll need that, but we'll see. We'll see how it evolves, right? Colon equal plus minus, and then we have type at the end. Yes, that's just gonna be a type. We can't really print that. We'll get to better printing later. Okay, so in the token, we have the variable value. Token type. Okay, and I guess we could just put the value in here. So this will be a type, right? So as a type, right? So var value doesn't really make sense in this case. And I should probably change that because we might use that for something else. But I think, yeah, let's rename this actually. So I don't think we use any more. So we should be able to just do this. And this can be a token value, you know? Because I think that makes more sense. And then we'll make var value for the actual variables. So token value. Yeah, I don't know why I would do it like that. But that should fix it. Then we need token types, right? Or not token type, but type. Like that. You know, so these will be type. So we'll have the different types in here. So we'll have type int. I don't think we have that already, so let me make sure type int. Yeah, that's the only place, so we're good with that. And that's all we're gonna have for now. But in the future, we'll have, you know, type stir, type character, type float, things like that. But now we'll start with this. So we can get the type, right? Based on it. So we'll have int. So this is really int 32. So maybe I should call it that anyway. The highlighting doesn't exactly work. I'll fix that later. Yeah, because this is gonna be, well, really it's an int 64. But usually just int is int 32. So for now I'm just gonna call it int, but we'll update the name as necessary. Once we add more data types and stuff. Okay, so I think that is it for that. So now we just need to actually update the lexer. So, hang on. I am a little lost here. Okay, I think this is, yeah, this is the lex. Okay, got a little lost. Let's see. So, let's do, I don't want to do this. Basically, I want to take that, so to create it, but we need to get the value of it. But we can generate the word, right? And how do we do it up here? We should probably make a function which returns the type, right? Right, is alpha. So let's look at this. Yeah, and then we get the word here. So let's actually get token type. So that's where we can return it. Yeah, that makes sense. Okay, so then we'll do else if is in is type, right? Well, is data type. Just so it's more clear, right? And we'll pass the stir in there along with the stir size. That could just be a string view. I don't know why we do it like that. And that would just basically loop over the existing types, which we'll do that later. Then we'll return TT type. And we should probably also return the value of it. So how do I want to do that exactly? This should probably be something different. Yeah, maybe I won't call it from here. Alright, let's actually, let's do this a different way. So I'm going to update that so that the natives actually are handled a bit differently. For now, I'm not going to worry about that refactoring. One thing at a time, you know? So let's do if, is data type. Word.data, word.count, right? So we need to pass that. Then we want to actually set it to that. So we actually want to, token.type equals, so token.type equals TT type. So we need to set that. So we'll basically just nullify this. But we also need to return the value here. So how am I going to do that exactly? Because I would like to just be able to call this once, rather than having another function called to get the data type. Because that's the enumerator. So I don't want to do that. Basically, dot so I could return a struct from that. I don't know if that's a good idea though. What if we pass the token in here as a pointer? And we can actually modify the token in there. So then yeah, we could do that. So is data type. So that's actually going to modify it. So let's do that. So let's do void is data type. So data type. Okay. We'll pass the token pointer in there, and also the stir and the stir size. Okay. So if we can move over the token, right? I equals 0, y is less than so we don't have that yet. I'm gonna have to define it. Less than let's see. Give me 1 second. Okay, sorry about that. So while it is less than the token count, right? Or type count. Data type count. I just want to make sure it's clear, right? And this will probably be actually data type count. So it is gonna be a macro. So iterate over that, and then if view equal, right? View compare actually is what it's called. I want to compare that. So this is actually gonna be a string view. So this will be. So we'll have the data types I, and then we'll have the create, do create, what function called, and we'll pass the string and the size, and that will create it, right? If it's one of those, then we'll set the token type, token arrow type actually, equals token type, and then token value type equals well, so the data types I can actually cast it if we do in the correct order. Data type I, like that, and I think that'll work. Let's see. We should have data type, right? Well, we have type. So that's actually what it's called. It's probably called data type. Well, no. I think I'll leave it as type. Might change it though. Okay, and then we'll have the actually it's not gonna be that. It's gonna be a string view array. String view. So this data. It's gonna be a string view because then we can compare it easier. So it's gonna be a little bit basically dot length. What do we need? We need the dot data equals it is, what is it? Yeah, so we have int. That's what it is. And then dot len equals we'll just do 3 because we know what it is. Okay, and that's gonna be it for that. So that will be all the data types, right? And we'll add more later, obviously, as necessary. So let's search for where I have data type, and I'm gonna change it to type. Whoops, that's not okay. Something weird happened. What is this? I think I can fit out of this. Hang on. Something, what was that about? Type, how did this happen? What the heck? Token value, and then int. I don't know what happened. And then this is token type. Type. Yeah, okay. Type, so this should be a type. I don't know what happened. Okay, type int, and then we'll have string view types equals data types. And let's define, well, actually, no, let's just use type count like that, and that'll be better. Then we can use that type count, and this needs to be actually a comma, so we'll do that equals, and we'll put the string in here. So dot data equals and dot len equals 3. Okay. Hopefully, we didn't mess anything else up too bad. So let's go to where we do data type, right? We don't have that now. Shoot. What happened? Did it remove everything that I did? That's the only problem with using your own text editor. Sometimes weird stuff happens, and I don't know why. Okay. What is this? How did this happen, right? token type. So we don't need that. If let's actually do handle data type. We need to pass handle token word.data word.count. Okay, and then let's actually pass it just as a string here because that makes more sense. We create this. Okay, handle data type. So we need to make that again. I seriously don't know what happened. Token type. Only token rather, and then string view. So, what the heck? It's frozen now. I don't know what happened. Hopefully it does not crash my computer. It's not. It's using a lot of CPU. It's trying to do something very weird. And I don't know why. What the heck? Okay, this is not good. I've not had this many problems before. I'm gonna have to kill the king. Okay, let's see. Let's see. Did they just remove everything? Okay, so we still have that. We still have that. When's the last time I said? What is this? Like, how did this happen? I don't understand. Like, I don't know what would have caused that at all. Frustrating. Okay. Okay, so we still have this. So we're back here now. What is this? What the heck? What is all this stuff? I don't understand. I don't know what happened at all. Okay. Void handle data type. Token string view serve. Okay. We have that now. And it worked. It actually worked. Okay. For size y is less than type count. I probably did. I think from data count. If you compare sir and data types I, then we want to return. No, we want to say token type equals TT. Actually, this isn't even meaningful. We can just return token type equals TT type, right? And then token dot value dot type equals cast to type I. Okay, yeah. So we just need to make sure that they work like that. Return token. So this is going to actually return token, and we need to set it like this. So we'll just set token. So if it's not any of those, it will just return the same token. Okay, now we have a lot of issues. Token is up. Token is up. I imagine that's where a bunch of things got broken. What is this? What is wrong here? Token has no member named type. Let's look at token. Let's go up here. Token, did I break token? TT count. Wait, we're missing stuff here. So we need, oh shoot, we need all the extra things I added. So equal, we need colon. It's one of them, and ident. Okay. And then type. We need that. Okay, so after exit, we need ident. That's not after exit, so I don't know why I did that. Then I'm gonna actually use that. Okay. And then after ident, we need colon. So then equal and plus minus. Okay, and then we need type. Okay, save that, and what else is wrong? Okay, token has no memory type. So what is that about? Where is the token? Oh, it's about wait, what? This should be what? Token value. Why is this here? We need token type. Token type. Okay, something got messed up there. Alright. Those are not handled, that's okay. And so type token point to 336, so that's pretty easy to fix. There we go. Build it, and let's see. Token is not. Why is it not? We do have tokens. What's the issue? Token is right there. Oh, okay. Data count. What is it called? Is it called type count? Or did I not actually add that? Let's call it type count, and let's put it there, because I guess it got removed. Where is it? Where is it? We do have type count, so what's wrong with that? Type in. For type in. Type def struct. Huh? I don't understand what's wrong there. TT count, that's fine. Conversion to non-scalar type requested. Okay, so it doesn't like that. Where is type? Okay, we have that. 284. It doesn't like something there. Okay, I think we have too many of these. Look at that. Okay. I don't get what the issue is with the type int up there. Type in, type count, that's fine. We're not missing a semicolon anywhere. Alright, I don't think it likes that, so let's just get rid of that for now. Okay, so type count, let's get that working. Why is that unclear? Fire qualifier list. I don't know what that means. Okay, it's supposed to be an enum. Yeah. Okay. So that fixed that. And then I think fix our other problem too. Let's see, where is it? Right here. So this should work now, because we're trying to convert to a string. Type count. Type count, let's see. So we have somewhere else we managed to find? I guess we do. Shoot, that should be no type. Alright, we'll just call it data count. Because it's a data type, so data count. Data count. Alright, that's fine. Oh, now we just need to handle that in the switch statement. So 5.8. Yeah, so just we'll just pick them all again. So case tt colon case ident, which we're actually gonna do stuff on the ident one, so temporarily gonna be there. TT what is the other one called? It's equal, and then you have last one is TT type. Okay, I think that should be all again. So it is compile now. Okay, so we should be able to lex it, and I can make sure as well. If I print tokens, right? Print token array tokens, and I'll just return 0 there. And if I build it and run it on Kano.Kano, invalid token x. What? What? Okay, that is interesting. Where do we have invalid token? Right here. So, if it is TT none, oh shoot, because we did not set it as that. So if it's TT none, then we just want to consider it a equals ident, right? Yeah, because that otherwise it's gonna be that. And we need to set the value as well. So we have to just set it to a string basically. Let's make an ident value, and it's gonna be a string view. Well, it's just gonna be the same thing. So, and let me look at all the values that we have. So we have a string, but we really want as ident, but it's gonna be the same thing. Well, hang on, is there anything else that we need to start with it other than the name? Not really in the token. So let's just let's do string view ident, and we'll throw it there, even though it's the same thing, but that way we can tell what's going on later. Okay, so ident token.value equals where we and value dot item equals the word. We create word dot data word dot count. Okay, so that should work now. And it's cheeky ident, that's my bad. Alright, build it now and run it. Okay, so we did get it now. So we have write, hello world, ident 1. So ident 1, why is the value 1? Oh shoot, because we don't handle that when we're printing it, do we? Token types, wait, what? What? Oh, I'm trying to print the value as a string. So what if we try to print it? We should probably switch over it, so I don't know why I'm doing that. But try to print it as that. Ident is still 1. Should not be though. So it did not get set properly. Did we set the value somewhere? Then we append it. I set the value dot string. It's not working. Where's the data? That's not right. So we have this string there. Let's look at how we parse the string, which is right here. So we chop all that off, and we append the append word dot data. What? Okay, we're just appending the word. Okay, send it to that. And we do this. Is this not the right place? What if we put the type in here? So print that token.value.item. Then we see what it prints out. We can do dot data as well. I think that will be fine anyway. Okay, I guess it was not fine. So let's do view print with a new line, and we will just also do view arg and like that. There you go. View arg, it doesn't like that. We don't want the dot data. We want that. Okay, build that and run it. We get X, so we do get X. We can change the inside identifier as well. So let's do foo, right? Foo. We do get foo. And now we get ident 12. Oh shoot, wait, is that the value? Oh, that's not good. Because then we have type. We don't have colon, but where's the colon as well? Did we consume it actually? We might be consuming the colon. Consuming the colon. Okay, so I think we need to view chop left one last time. So how can we do that? Do we do it at the bottom? We do that. We can't really get rid of that unless we move it into each one of those. So is there something else that we could do? Alright, we'll just have to put it into each of these. So world plus and do that. Here and do that. Here and do that. Alright, but for this one we do not want to do it. No, not for this one, for the other. Okay. Build that and run it now. And it gets stuck forever. Okay. Do we still want to view? Let's do an else as well. Okay. There we go. So now we still don't have the colon because we don't. I'm stupid. Okay, let me undo some of this because we do not need that. That undo did not work. Okay, there's some issues with that, clear. But we don't need that. But we need to DA append still. DA append to. Got rid of DA append from everywhere. Oh shoot. Tokens. Token. Yeah, okay, the undo has some issues. Needs further testing. as well. Okay, so yeah, the issue was we didn't actually like it. So we still want to do a view chop left up here, and we need to do else if view. Actually, let's go to where we have it's not really an operator though, so I'm not going to put it there. Data equals. Then we will token equals create equals I can equal dot type equals tp equal, and we don't need a value or anything like that. So I put back all that we need. So then we can be okay. And let's save that or build it and run it. There we go. So now we get the equal, and we need the colon. That's something else I was doing. Okay. Else if we got data equals colon, then we'll do this, but with the colon. PP colon. There we go. Get that and run it now. So, oh, we don't need, we need a location as well. So let's do dot lot equals location. Let's see. So we need row and column, and here as well. Dot lot equals location, row and column. Okay, that should do that, right? Column does not exist. Shoot, I need to do it like data minus start plus 1. Data minus start plus 1. Okay. And it does not work still. Okay, so we need to set as well. Okay. Don't have file name, do we? Let's just do dot row equals row. Dot column equals column. Okay. Then it should finally work. Row equals row. Column equals that. Okay, and it compiles, and if we run it, we still don't get the colon. It's probably because it's directly after it, isn't it? If we put a space there, then it works, does it? Yeah, so we still are consuming one too many. It's not good. So I guess temporarily we could just subtract it, you know? Well, hang on, is there any way we could chop up ones? We got data plus 1. Could we do that? Data plus 1. Yeah, I think that would work, right? Put in 1 in that. Whoops. Okay. Right string ident, and we don't get it still. What the heck? Alright, what if we just do data minus and view dot plus plus. Wait, we decremented one. Then we get it. Okay, so I guess I'm just gonna do that. At least for now. I'll think about something better. But now we can actually parse them. So we have right, we have ident, but the 12 is still not right, so I need to figure that out. We do have it correct here though, so I don't know why it's printing 12. Then we have colon, then we have the type, which is int. We have equal, integer, exit, and integer. Okay. What's the deal with the identifier? I don't get that exactly. Let's print that. New print. New line. Data I dot value. What is it? Yeah, view r dot value dot ident. View r. Because it works in the previous one, right? And why is it 12? What is the 12 about? I don't get that. But we can't use the word like that because we need to allocate it. Well, Hello, Noons. How you doing? Uh-huh. It's right there. This shouldn't modify it. So that's fine. Does it though? Finish the one where you talked about the parser. Okay. Well, I can quickly go over what I did if you would like me to. It's really not it's not that complicated. And it's rather similar to the one that you did as well with the Pratt parser. Okay. The ident. I can print it here, but not. Equals that. Oh shoot, because we free the word data. It's not equal. Well, no, let's just allocate a new one. Actually. Is there actually stir dupe? This allocates it, right? But that's not really gonna work with the string view. Noon's short on the end, like nuns. No need. We'll see the video. Okay, so hang on. Let's see. So I'm not sure. So noons, like nuns. Yes, noons, like that. Sorry, I have a hard time with names. Yeah, okay, good. Equals times character times Portuguese surname. Cool. So you are Portuguese? I Finish work. Okay, because the problem is we were freeing it. Let's use let's and pass the null here. What's best with the word dot count? Now it's 7. What? Okay, so it's reading random stuff, so it didn't work. I didn't word dot count, huh? Oh, because we did not copy into it. So let's do copy ident from word dot data word dot count. So I probably make a function for this. Just like it even be from a string view to create a new string view, where it allocates and everything. But there we go. So now we actually have the identifier. So let me get that and go to print token array and get rid of this. And whoops. Save this. Let's go here, build it, and run it. Okay, so now we have all the stuff. So we have the identifier with the name. That the type. Okay, so that's pretty good. Okay. Now I think we can move on to the parsing, which should not be too difficult. So let's go to the main parse function. Let's see. Parse expression, but parse. Okay, so if we have an identifier, in future it's gonna be more stuff that it could be, but for now it's always gonna be a variable in this case. So we're going to expect it to be a variable. So we're gonna look at the next token. Oh, how do I want to do that actually? So when you create a node, first of all, node, and then honestly, we'll initialize it for now because I gotta hit. So the node, we're gonna need to add all the types for it. We're basically gonna save the variable to a different struct, so like the program state probably is what I'll call it, something like that. We'll have the variable, and then during the actual compilation, we'll figure out the position of it because it'll be stored on the stack. Want to see my new project? Sure, for sure. Don Ho followed. Thank you. I appreciate that. Okay, let's see. Parsing. So we need operator types. We don't need more of those. Quixler. Okay. I'll take a look at that in just a second. Let me just get the structure figured out here, and then I will take a look at what that is. Is there anything here? Expert, we don't need to change that either. Variable type. So, yeah, we don't need to change those. So we can have a variable type. This is arg value. We don't have any args right now, so that's not relevant. Arg type, we don't need that either. Arg. Actually, we could have arg identifier, but we'll get into that later after we get the rest of it figured out. So there's a lot of stuff here. Native call, we don't need that. Okay, so now we have the type. So we'll do type. Really, it should be prefixed with node. So I don't know why I called it like this. But let's do type variable. Maybe even just var. I think var is reasonable. Okay. Node types type count. Alright, I guess I did not add them up here. So expert and var. Okay. And then expert. Okay, so these are all the values. So native call, or we could have a variable. So variable var. So we'll make a variable struct. So type that struct variable. So this is gonna have a var type. Right? So that's gonna be the type, and then it's gonna have an expression, which is the value. Will it just be that? I don't know. We might have to make it a pointer, but I don't know. We'll see. We'll have an expression for the value, which we will then evaluate, right? And then we're gonna need the scope, right? So this is really gonna be the stack position when it's created, right? Because we're gonna plot the stack down. That's gonna be based on scope though, and that doesn't matter until we actually introduce scope, right? But that's gonna be stack position, so we'll need to store that. That will be done at the generation time. And we need the name as well, obviously. So string view name. Okay, so var type. Let's see, where do we have var type? That is up here. So var string and var int. So that should be good. Okay. And then this location, value, and type. So that should be all good. Yeah. So that should be perfect. Should it be a perfect? So yeah, let me take a look at this Quixler with Zig. That is cool. Very cool. Zig. I've not used Zig before. Okay, so build.zig. Yeah, so Zig is you build it with itself, right? Wait. Still making the readme. Okay. Yeah, well I can wait a minute then while you work on that. Just let me know when it is done. Okay, so in here, the node type is gonna be pt variable. It's gonna pt var, not token type var. It's gonna be node var. Okay, and then the value, it's gonna be based on other stuff. So type is that, but then the value dot var dot type is gonna be based on the next token. So then we should probably expect token. And I don't know exactly how you use this again. What do you have to pass to expect token? Tokens and then the type that we expect. So we're gonna expect a colon. And then token type colon. So we are expecting that. That's just so that we know. And then the next one is going to be I'm gonna just add all of the expect. And then we're expecting an equal. No, a type. Token type. A token type. Yes. And then an equal. And then one more. Well, then we just have to parse the expression, which that will handle that. So then we can do node dot value dot var dot value equals parse expr, and we have to pass. What do you have to pass to that again? Parse expr. We just need the tokens, and that's it. Okay. We actually have to consume all the tokens. So I'm just gonna do token consume. And I'll just do that 3 times. Actually, probably 4 times, right? Because oh yeah, but it has to go after this. So being a little stupid right now. Just like this. There we go. Token consume, and then the one more after that. Okay, and that should be able to parse the value. And we need to figure out the type in here before we consume all these. So the type is going to be based on what this is. So the token dot value dot var dot type equals the type of this. So yeah, so we probably use the type as the type. That kind of is a word. That was a sentence. Ooh, something's lagging a lot. I should say this, just to make sure. Yeah, let's use the type instead of the var type. So I'm gonna probably rename var type something else, but let's use type for the types, because then we can just send it directly, right? So equals the current token data 0 dot value dot type dot type. I think that is what it is. So we have that. And then we have the equal sign, which doesn't really matter for anything right now. Just we need to know that there's that. In the future, once there's more stuff, these will give us hints on what is going on. So let's try to build that. Statement may fall through. I forgot the break. Okay, TT exit is not handled. It is handled, so what's the issue? Okay, I think... Okay, so it wants us to pass the token. Let's do this. Tokens.data. I can do that. Tokens.data. Data. I put that in the wrong spot, so no, I didn't. Okay, tokens.data. Let's do that. Build that. Wait, token array, but argument. Okay, parse experts. That needs to be a point. Type expert. Yeah, so this has to be a pointer to the expression, and that's okay, because it is allocated and such, so we're all good with that. Nope, don't get rid of that. I didn't realize that. Okay. So we need to modify this to have an expert pointer. We don't have set stack position yet. What you working on? I am working on the compiler to a language. So let's see. That's the wrong place. In here, so it's called KanoScript. I'm gonna integrate it into my text editor as the I need to ignore that as the scripting language for like plugins and configuration and stuff. And right now I'm working on variables for it. So able to do this, declare variables. Yeah, that is what I'm working on right now at the moment. Notice set but not used. Yes, we don't need that's okay. Nice. Handled up there though, so what's the issue? What's it look like? Okay, well it's not much right now. But basically here's the language. So this is what we're on now is for the variables. Right now, you can call write, which is just basically calls the calls a write syscall. Yeah, and then we'll write this string, or whatever string you pass, to there, so you can pass whatever, and it will pass it. There's a few escape characters that we support, like that, new line, and tabs, and things like that. You can exit, which just, exits, with any value or whatever, and you can pass expressions as well, so like 5 plus 3 times 27 plus 13, similar, or, okay, 13. And that's pretty much all that we have right now. Yeah, I would like to get variables now, so that's what I'm working on. Yeah, that's pretty much, that's it. So far. Done. Okay, I will take a look at that. I see, no, it's right here. Alright, read me, let's see. Simple lexer implemented in Zig, nice. Parsing technique. Okay. No let keyword, nah. No. Yeah, so basically, subject to change, but right now, basically, it just starts with the identifier, then, depending on what's following that, it will figure it out, instead of what's preceding it, It'll figure out if you are declaring it here, or if you are assigning one, or if you are once there's functions, if it's a function, things like that, basically. I don't think the let keyword would be needed. Okay. Okay, the lexer takes source code input and breaks it down into tokens. Alright, nice, nice. Use it, ensure you have Zig installed on your system, clone the repository. I don't even know if I have Zig installed. I did not have it installed. It's installed. Okay. Kind of big though. What the heck? It might take a minute. Okay. Clone the repository and do that. Then you can build and run the lexer using the Zig compiler. Okay. Source code snippets. Alright. And does it print it to standard out then when you run it? Zig run build. Kind of first. Run build. Okay. Read that and then write your input. For now, still being implemented. Okay. Alright, let's see how it works. So it works like your other parser that you showed me, right? The Pratt one, right? Same way. How do you know if the variable is being updated or declared without a let keyword? We can look at what's following it, right? Like, so if it's being updated, you'll have that. So if it's not followed by a colon and a type, then it is being updated, right? Like, I might be missing something, but I'm pretty sure that's all that you need. Top. Update based on UC. You won't have the Python problem. What do you mean by that exactly? Make it your own language. Nice. Should know. Okay. Yeah, so this is the lexer. How it works in Python. Oh, well, it is different because it is like in Python, there's no difference than declaring it and updating it, right? But this, there is actually some added syntax, right? And the occasional need for global. Yeah, I don't think that'll be a problem. If it does, then I'll just add the keyword. But I'm pretty sure it won't be. But obviously, I won't know until we get there, right? But I'm pretty sure it should be fine. Let's see. But I am thinking about, so like for functions, I might need a keyword for that. But I'm not sure, like a fun keyword. So, fun. Something like that. But I don't know if that's necessary. Because you can just look at the following tokens, and you'll know it's this. But then when you're calling it, how are you going to figure out the difference? Well, it could be the same way, right? So the return type would be like this. I don't know. I'm still thinking on how the syntax is going to look. And it might need to be updated based on what can be done and what needs to be done, right? I don't know. I'm pretty sure this will be fine. At least for right now. This will work. Or should work. Okay. Yes. Pretty cool. Times. Fine. Okay. Pretty simple then. Makes sense. AST. So it's just like defining that. Yeah, I'm not used to Zig. Looks pretty C-like though. Maybe C with some rust. Parser. Nothing in there right now. It's almost C. Yeah, I've heard it's like the successor to C or whatever. Is this actually empty? Or Batman? Okay, so I guess you haven't implemented those yet. Very cool, very cool. We'll definitely follow that. I'll start it. Only AC and Lex are done now. Okay. Alright. I'm gonna get back to this. Parser's next. Nice. That makes sense to follow that. Okay, so here's what we got now. Where was I at? So we're setting the type to that. Oh yeah, we're trying to build it. Let's do that. Build. PTX is not handled, but it is handled. So why does it? Ooh, because we have this J here for some reason. I'm not sure how that got inserted, but that was the issue with that. Node set but not used. That's okay. Token array, but that is that. So these need to all be pointers. Say it uses a Pratt parser. Yes. This one is a Pratt parser, I think. Yeah, Pratt parsing technique. Here, I can put the link there if you want to look at it. But yeah, like he said, it's not done yet. I did token array, but argument is token. Okay, that's not good. So that is supposed to be a token array. I thought it was not. Build it and spec token. Wait. Token array. So it's supposed to be a pointer? Is it really? Okay, getting there. Oh yeah, Pratt calc. Yeah. That's the other one. Oh, it's in Rust though. So not to Zig. Type in something that is not. Okay, so I'm gonna look at that. And let me look. Well, hang on, let me get everything figured out first. So token undeclared. That's a node. Okay, so it doesn't like that, and no rar undeclared. Why is that? Is it node a variable? Perhaps? It's not. Okay, let's see what the node type is. Okay, I guess it's type var. Type var. Okay, and then the other thing was, yeah, so the token type, right? At that token type, and we need to look at the value of it. Token value, so token type, type. Okay, so I think we can just use the type. It's kind of confusing to say, okay. And type. Okay, build that. Now node is set but not used. That's okay. So we're going to DA append it. That should be all that we need to do here. So obviously this is not exactly optimized, but should be able to append it. And then I think if we try to print it, 0. Video has those two game devs who are always ragging on other devs. Who is that? Okay. And we would just print the type of it, I suppose. Okay, types. I. Yeah, that's all that we need to actually, that's not right. We need to do root.count, root.data I. That needs to go in the types. And it's going to be dot type. So that was kind of mess the type, but done. The videos are interesting, but Jai seems to have gone nowhere. Oh, so you're talking about Jonathan below? Affected type. Type but found type equal. Okay. So where is that at? So we put the wrong type there. Also, there is an issue with that. So type. So that's in the print error, actually in the macro definition. I need to put a space. There we go. Yeah, so let me look at why that happened. So we spec token that. The type should be after the colon though. And it is. Wait, oh shoot, does expect token iterate it? Probably does, because we've had this appointment, so we don't need to consume it. expected integer but found equal. So did this one not consume it? Why did this one need to do that? Equal, and then there is an integer. Also, I don't know why this is so messed up. I need to look at that. The column is not right. Oh shoot, is it because I don't reset it? Oh shoot, yeah. Okay, I know exactly how to fix that. Yeah, we'll get into that later. One thing at a time, right? Parse expert, so we need to token consume that. I don't know why we need to do that though. Assertion failed, unreachable. Okay, that's probably in. No, it's in. Oh shoot. We need to consume one at the end. Yeah, so that's what we had to do. So native and var. So we do have a variable. So why did we have to? Yeah. So we have this. It's kind of weird though. And then, yeah. So why do we have to consume after this? So would this expect token consume or not? Shoot, that's not gonna work. Expect token. So we do consume. Let's see, but it doesn't. Yeah, because we consume the first one, and it looks at the one after that. So we do need to consume it. That makes sense, actually. That makes sense. All right. So we did. So that should have the expression in there. So then, let's see if data I type equals type bar. I think that's what it's called. Then we want to print expression of the root.data_i.value.var.value, and that should be the expression, I think. And run that. Int 12. Okay, so that's all that we have for now. But we should be able to put 12 plus 5, right? And we'll print that out. Like, not actually as a tree, though. It seems like not just 12. That's not good. Integer plus integer. And what if... root.data_i.type equals type native. Well, hang on. That's not good. Int 12. Is the print expert broken? Is there something else wrong? I'm trying to print the expert in here after we actually build it, right? Like that. Whoops. And run it. Let's see if... Yeah, it just says in 12 there as well. So is it not building it properly? Or is it only printing the first one? I guess it could be broken. Seems to... Okay, that's not good. Did we consume too many tokens? Oops. No. Unreachable. And what is... Let's print the token type as well. Like that. And we should be able to print it out. Token doesn't exist. It's data I data 0 instead. Type is integer. So we're on the integer. We print out the value. Integer 5. So we're on 5. Yeah, so it did not parse the expression properly. It should though. Parse expert. Oh shoot, that's not supposed to be 11. That's supposed to be 1. Okay, that's probably the problem. Maybe not. Yeah, well now that tree is right. But then the assertion failed because we need to consume that last time. Okay, 1257, so that's right. Ah, yeah, we printed out twice now because we printed there and we printed here, but that seems to be right. But it did not build in the proper order because we had the variable after the second call, which is exit. Why did it do that? Um, mm, Not in the compile, but in the actual parsing. Why would that happen? So we have right. Oh shoot, we have a second right. Why do we have that? Oh, because we do have that. Okay, so we don't have the exit. That's what the issue is. Why not? It's on integer 0. Right there. We consume 2 minutes. No. Is that right? Then we're here. That's fine. Did that work? No. We're still playing on 0. So we're not handle this. Maybe I should use GDB instead through it. Yeah, I don't see any exit there. Let's see, if we put this one back. Why is it plus 0? What? Oh, shoot, tokens data. It's a plus? So then we're on a plus. Okay, that's what the problem is. Let me modify this again. Whoops. Run it. Then it works. But we still don't have the exit. We have it here. So it must be consuming parse expert. I didn't even consider that. We might be consuming too many. Let me get rid of this. I'm gonna have to consume the tokens here. So token consume. And run that. Okay, integer 0. So we still fail on the 0. And we don't get into the exit one. So we consume too many here. I think that parse expert is consuming too many. Alright, then we get to the exit. So that is interesting. Alright, let's do some GDB, right? Enable environment. Well, I want to break on parts. And I'm just gonna continue to the next one because it's gonna break on main first. Okay, parse. And let's see. So yeah, when we print stuff out, problems happen. So root that, and we go here. Right, so that's all good. And then we have right again, that's all good. Then we have ident, that's fine. Data is 0. Let's look at that. That is the type. So, but the one after that is equal. So if we look at tokens.data 1, it is equal. So that is what happens. So then we consume that. So let's print tokens.data 0. So we consume that, and then yeah, now we're on the integer. So we parse the expression with the integer. Value. Oops. Alright, it's gonna be kind of the value.var.value. Maybe not. No, it's print. I'm not very good with PDB, sorry. Okay, there we go. So I have the left-hand side and the right-hand side, and it's a plus. So that's right. We append that. Then we go here. And let's print tokens.data is exit. So we are on exit. Exit. Okay. And then we parse that. And then we try to consume at the end. Okay, so that's what the issue is. So we don't want to do that. If the tokens is greater than 0, then we do want to know. In that case, that means usually we won't put stuff after the exit, but if you do, then we have to handle that. All right, there we go. So now it actually compiles properly. Okay, and that's the proper expression. We have 12, 5, and 7. It doesn't print it out like a pretty tree or whatever, but that's fine. Okay, so now we have to generate. So we have to handle stuff, and it's going to get a bit more complicated because we have to set the stack. We have to keep track of actually where the stack is. So first of all, we can generate it. And yeah, we just need the stack position. Right. Okay. And that's how we're going to get the value of it. So we need a way to keep track of the stack. So I'm going to need to think about that. But let's do case. Not native, but node. Okay, that's only if it's a native actually. So we need a case for not a native, but instead a type var. Okay, so let's actually add that. Whoops. Great. Okay, so what we need to do here is we don't need the arguments, but we need the variable name, which is how we're going to keep track of it. Right. So actually what we need to do first is we need to create some sort of state struct where we can store all this stuff, right? So let's do perhaps right here. Struct. And this will be program state, right? So we'll have the variables in here. Variable, but we'll actually have a list of variables. So let's go up to the variables and we'll make just a dynamic array. And in the future, perhaps I will like make it into a hash map so that we can just grab it by the variable name instantly. But for now, I don't feel like that's necessary. So we will have variable data. So that will be an array, right? And then we'll have the count and capacity. Okay, so we have dynamic array variables. So this will be variables bars. Yeah, so we'll store it all there. So this is like the symbol table or whatever. That's basically all that we need to store because the variables will have the information stored within them. So what we do when we encounter a variable declaration, so this should probably be type var dec, right? Like a declaration of it. And then we'll have var reassign, right? Yeah. So let's make that, let's call it that. Type var dec. And token type token type item actually. Yes, we'll do type var dec. And then in the future, we'll have to actually look at the next tokens and then we'll figure out the type based on that. So if it is dec or reassign, right? Or we're actually using it, but in that case that would not be in the node, it would be in the expression, right? Okay, so in the case of a var dec, then we want to actually push it onto the variables, and we need to keep track of where the stack is at, right? First of all, we append to the program state, so we need to actually pass that as well. Program state. And we want to actually modify it, so go ahead and do that. So we're going to need to initialize it. Let's do it here, right? State equals 0. Okay, and we'll just pass the state there as a pointer. Alright, so we can de-append to state, and want to append the node value, right? Node value.var, like that. That should compile. Program state, oh shoot, it's program state arrow. We want the bars. I forgot about that part. Okay, then that actually does compile. So that should be pushing it. But first of all, we need to get the state of the stack, right? So we'll actually probably store that in the program state as well. Like the current stack size. Program state. If I can. And not type. Program state. Stack size, right? That's the stack in the virtual machine. So whenever we push or do anything that consumes it, we need to either add or increment or decrement the stack, right? So we have push here. So I'll probably make like a wrapper function about it, right? So like push, oops, push, and then for now we can just pass an integer, but in the future we'll be pushing like floats and stuff like that, so we'll have to pass the union, and then we'll have to pass type as well. But for now, we don't need to do that. So let's do generate gen push, right? And we need to pass the file. Oh yeah, standard out. Okay. And then the value, so standard out like that. And that is the integer value. So I will make that. So void gen push. So it takes the file and the value. So we will just fprintf file push /n value. Okay. I did not spell that right at all. Fprint. How did they mess up that bad? Printf. There we go. And that's it. Okay. But we also need to increment the tag size. I forgot about that. So we need to pass the state here. So program state. So we pass it. Okay. And then also push stir will increment the stack as well. So we'll make a push stir. Basically every instruction is going to eventually have this, right? And we want to pass the view that we're going to push. So it's always pretty much going to be a string view. So we will pass the node value.native.args.data 0. That is it. Value.string. This will pretty much always be a string view, so that should be fine. And push stir file and then string view value. A little bit indented, but that's fine. Alright, push stir, view print, and we want to just put value here. Okay, and that should print that pretty much. So we want to actually say, yes, so state stack size plus plus. Stack size plus plus. State stack size plus plus. Okay. So here we need to pass the state as well. Alright, and that should be fine. And then native that is going to actually decrement it. So I don't want to handle that. Because that's the type. In the I don't know. I'm thinking. So because that's gonna decrement it by 2. Or yeah, by 2. So I'm just gonna do that for now. But I'm going to need a better way of storing the native variables and then the amount that they decrement the stack by, because then we'll be able to just decrement it by that amount whenever we call a native function. But for now, let's do that. And then here, we need to do this as well. And then also in the evaluate expression, we're going to need to handle that. So exit, compile expressions, we have that. And then we have this, which is going to decrement by 1. State size, and then this compile expression. So let's go in there. Compile expert. Actually, I'm going to need to grab, bring these up a little bit. Just all the way above all of the parsing stuff. Just like right here. Okay. I'm just gonna give it a bit. Okay, so compile expression. Anywhere where we are pushing. So this calls that. So push. So this is going to be a push. Push file. We need to pass the state. So we're going to have to pass the state for this as well. Program state. Okay. File push, and we're going to push the value. So that is the value. So we don't need this part. That should generate the push, and then this is going to actually consume the top 2 elements of the stack. So this is going to always only take 2. So we can do state stack size minus. So we have that. And gen push. Yes, we need to pass it to wherever we call it compile expert. So here we call it pass state, and then we also call it in itself. So okay. State and state. And I'm pretty sure that's it. It did actually compile. That's cool. Let me get rid of this print stuff. What I'm going to do now is set on the node value.var dot right position equals state stack size. Okay, and we also need to well, we need to actually compile the expression first, and then wherever the stack is at that point. So let's do that. Compile expert state file the node value dot var dot value. I think that is it, right? Yes. Okay. So I run it now, and it printed out exit still. So let me get rid of that. There. And if we look at kmail.tasd, we push 1. Alright, so that is the right. And then we push 12 and 5, and we add them. Push 7. So why are we pushing 7? Add. Okay, so I don't know. So we don't ever actually use it. But what is the 7 for? Actually, we do have plus 7 here. So that is why. Okay. So that'd be 12 plus 5, right? And then plus 7. So that's actually right, I think. And that should be the position on the stack. Hopefully. Alright, so then we need a way to actually retrieve the value. So what I'm going to do is add it to here, right? To the parse primary. And token.type is not equal type item. Okay, so what is that? That's still just going to say int, but that's okay for now. We're going to create it. So if it is int, then we want the expert to be that. So if type was type item, then do this. Actually, got to do it like that. Otherwise, we will initialize it a different way. So expert, so it's expert item, and then value dot item equals value dot item. Okay, token dot value. We have the item value, right? I think so. But then, so we need to modify the expert to have an actual identifier. Z docs are so bad. Really, they're bad. Like, how bad? Okay, expert, there we go. So we need expert type item. So, so chaotic and poorly. Really, I'm actually kind of surprised to hear that. They have Ziglings though, so that's like the rustlings. Is that it? Let's go to var variable. So that's what we want. So we want it as a variable. Ziglings, yeah. I see. Yes. Do we want the variable? All of it here. Do we need all the data? Rest is so chaotic. I'm pretty surprised to hear that. I think we just need the name, right? So we just set it to the name. Dot variable. For var. Dot name. We have. Alright, so it is just right. There we go. Okay, and then we have the name, and then we'll have to look basically in the in there once we so that should be able to generate actually. If I do kernel.kernel and I make this exit with foo, it should compile, but well, it's not going to compile, but it's good. It should fail on that step. Okay, detected integer but found item. Ooh, okay. Right. Where is that at? So it's here, expect token. So where are we calling that? In the exit, do we expect? Oh shoot, parse native then. Oh shoot, so we're expecting an int. Oh, I see. So let's get rid of that. But then it's all gonna fail because yeah, we need to consume that one. That's a double point. Unreachable. Yeah, so that is in here, right? In the compile expression. Yeah, so then we case expert item. And for now, we'll just assert false unemployment. Let me just make sure that it does fail here. Expert, yeah, it's very good. Or var. If we run it, yeah, unemployment. So if I just skip over it, it does compile. Okay, so what you do is look up there. Look up where it is in the stack. And then we're going to do undo, right? So that is the instruction undo, based on the current stack size minus the stack position. Is that right? So like if stack size is 20, which is 10, so we get the 10th one. Yeah, so that's what we need to do, the current stack size minus that. And that's going to grab that value that far down from the stack and push onto the top. And then once we do that, we'll have the value, and that's basically all that we need to do. Then we just have to exit with it. Or we need to, yeah, we'll have the value. So it's like pushing the value. So we can do that. So we'll make a thing like this for it. For value dot variable. It's always called it just wrong. Yeah, we don't have undo. So let's make that in the same place where we have which. Yeah, it's gonna be gen. Which inputs, yes, and then we'll have here void gen undo program state file, and then string u is the value. Yes, okay, so we're going to look it up in the state. So for size t I equals 0, well, I is less than state bars dot count I plus plus, and if you compare state bars dot data I dot name with value, then we want to basically grab that value. No, actually we don't want to do this here. Yeah, we want just an int value or a size t value, and we're going to generate that. And this is going to actually happen in that switch data. So yeah, file, so this is going to be undo, and then just the value. Okay. So yeah, we'll generate this value a different way, because that makes it more generalized. And we'll do state stack size plus plus. So we'll iterate the stack size. Okay. So I think that is right, and that will basically put the value on the stack. So we'll look here, and what we want to do is get that. So for size t value 0, so we can do that same thing that I was just typing out. State bars dot count I plus plus. If that's not right, if you compare state bars dot data I dot name with its for value dot item, then they're the same. So we need to get that index value. So let's actually do index equals 0, and let me index equals 0, and let's get that there, and this right there. Okay, and we're just going to set index equals state size minus state bars dot data I dot stack position. Okay, and we need to do, no, we don't need that. And then we're going to look it up based on the index. That should be it, I believe. Okay, so build that. value. You guys don't remember the name? I do. It is var. Okay, building. Very good. I thought that. Okay, yes I did. And kingdom.king. Let's look at kingdom.tasm and do 0. So we call that a bunch of times, which is not right. Okay, so we are setting it to var too many times. Why are we doing that? Oh shoot, because I did this backwards. This needs to be tt int. There we go. Yes. Okay, so now we're pushing on that. And at the end, we indupe 0. Alright, so it is on the top, I believe. So if we actually then build tasm, kingdom.tasm, build fire. So it might not work. We'll see. Echo that. 24. Okay, is that right? So 12 plus 5, so 17. It actually worked. So what if we declare another one? 8 equals 15, and we exit with 2. Is it still going to be 24? Alright, let's look at kingdom.tasm. Here you go, it's not going to be, it's going to be 15. So it did not work. 15, yeah. So why did that happen? We also need to make sure it exists, right? So this should probably be a function. So like next equals get variable location, right? And we'll pass the variable name. So expert value variable at the string, and also the statement. And yeah, we're gonna set index equal to that. And then if it is, let's actually make it do you want to make it an integer? Yeah, let's do that. If index equals -1, then we want to just print error. Actually, let's do variable that reference before assign. Okay, so something like that, and we're going to put the expert value dot variable, and it's not actually a string, so we can't do it exactly like that. We need to do this, do print, and we need to pass the view arg, like so. There we go. Okay, so yeah, now if it's on there, so get variable location, so that's going to be like this. So get variable location. So it needs to state actually program state, and string view. Right, and then we'll just iterate over it like how we work. Plus then state bars dot count plus if you compare state bars dot data I dot name with name, then return state bars dot data I dot stat position. Otherwise, we'll return -1. Okay, so that should almost work. We need to pass the location to print error. So let's just do don't have the location. Yeah, so that's an issue. So I will need to figure that out. Variable foo reference before assignment. Really? So it did not assign it. Okay. Did we not push it? Wait. A2. I thought we push it when we encounter it in here. Yeah, we gave append to state vars, node value var. With a new var. You arg node value dot var. Dot name. Name dot name. It's not the name. Okay, so the name is broken. Do we not set it? Wait. Type ID. Let's see. we do this. That's not where it is. In here. Not set the name. Set the value and the type, but not the name. Yeah, we need to set that. That's very important. So node.name equals node.value.var.name equals the token value, right? So data 0 dot value dot var dot ident. It's just ident. Okay. So that's kind of an important part of variables is the name. Foo and another. Okay, let's look at kano.tasm in dupe 3. Okay, so that is promising. I don't know if that's right though. It should be less than that, but we'll see what happens. So build tasm, kano.tasm, build tire, kano.tin, index out of range. Okay, so it did not work, and I believe that's because we're not keeping track of the stack properly. I would imagine. 7 push-up requests to do? Really? I don't see it. Wait, does that mean I have to do 7 push-ups or I have to do 70 push-ups? Is kind of a lot. So the location's not right because we're not. It's supposed to be 2. Okay, no. 7 push-ups. Okay. I will do that. Alright, it looks like that worked now. So in loop 1, that should be right. I will do the push-ups. Soon though, I'm gonna set up a webcam so then you'll be able to actually see me doing the push-ups. But I've not done that yet. Pog, Emacs. Alright, I'll do them right now. Done. Done. Alright. Yeah, that Emacs challenge, I think I'm gonna have to extend it. Because I would like to do that. That'd be fun. Alright, so this should work now. There we go. Okay. Try to add a few more and make sure that it works properly still. I've had it right here. 1, 2, 3. And then also, we'll declare another variable. The var 2. We cannot have numbers in it right now. Actually, we might be able to. I don't know. I have to look at if so. Let's try that. I don't know. So that should be 15. Kano. Alright, and let's look at the source code. So 2. It's hard to tell. Build slash tire, Tim. 24, that's not right. Quick, so we did this one. Okay, so somewhere we're not keeping track of the stack properly. So where would that be? So we push. The stir, that only pushes 1. 1 value onto the stack. And this consumes both of them. And then let's see, so this compile expression and native exit only consumes 1, so we only do minus ones. So let's see, it might be in here. It's in the compile expression. Oh shoot, did we not iterate it properly here? No, we should. This needs to be minus equals 2 though. Because we're consuming 2 values here. Okay, let's run it now. Whoops, that's the wrong one. 27. That's even more wrong. Now it's bar. Huh. Okay, that's not good. Alright, and it's starting to get kind of messy. Oh, I forgot to actually, when we generate the expression, right? Let's go to compile expression. Let's actually print expert here. And then also here. Yeah, we don't need this anymore. Just that we can read it a bit better. I'll open it in Vim as well. It's easier to see. So let me actually put that because I forgot to rerun it. Yeah, because I have an actual highlighting for this. So we have right. We have right again. So I'm going to keep track of the stack and see where we're getting it wrong. We add it here. We add it again. It only consumes one though because it pushes a new value on the stack. So that is right actually. The one was right. Because it consumes two values, but then it pushes one more. So it only consumes one. Yeah, that makes sense actually. Expert push 15. Yeah, so that pushes 15. I push all these. Another expert here. We have exit and another expert, which grabs the top one, which actually that's kind of wrong now because we're using the wrong thing. So if we open up like that, it's gonna be closer. So let's keep track of the stack and see what we have. So we have push stir. That's gonna push one on there, so it's gonna be the stir, right? We push int, and then we consume both of them. So the stack size is 0. And then we have the same thing, so that ends up with 0. Then we push int, consume both of them, but push a new int, then push another int, consume both, but push another one from the adds, both the adds. And then we push another int, it stays like that. Then we push another string, and an int, and obviously we end up back like this again. We push another int, so in loop 2, so 0 would be the top one, 1 would be this, and 2 would be that. So it should be grabbing that one. But that doesn't seem to work. So I'll quit that. Tired/10. Oh shoot, actually. It is grabbing that one, but it's not supposed to grab that one. It's supposed to grab another, which is this one. So, yeah, it's going too far back. Huh. Actually, I might have to do -1 since it's 0. Oh shoot. I forgot about that. So indeed. Yeah, we need to do value -1 since it's 0, 0 based. So now if we do it, I'm trying it a few different times because I want to make sure it works out. Kano.asm, and now it is 1, so that should be right. Asm, build/tired, Kano.10, and echo that. 15. Okay, and that's right. Let's modify this, and let's try food now. Make sure that one works. Wait, no, it's right. Let's see. Using Vim to edit Kano, yes. I need to make a syntax island for Kano. Like, I can do it pretty easily. I just have not done it. But it is fun. Yes, I agree. And 15, that is not right. What the heck? How did that happen? Huh? Yeah, the state is 1. Shoot. Hang on. So, position in the stack. Oh shoot, but we can move stuff out of the stack. I forgot about that. But we don't do that, so that's not what the issue is. But somewhere we're not doing it properly. So something here. So we iterate the stack when we do that. This is a problem. Assert this. So right. Push a string to iterate it by 1. So iterate it by 1 as well. So why does it end up wrong? Alright, and what is the... How do we set it to that? So we set it to the stack size. But, Do you want to do that before compiling the expression? That's obviously not right. Oh shoot, that must have been 0. Wait, what? Stack size is always going to be at least 1 at that point. Or not. Why is it not? Shoot, the indude. Okay, wait, hang on. Why is the indude so messed up? Oh shoot, because we're doing -1. We can't do -1. Alright, I'm having some issues, but let's see. Yeah, so then I got the 0 thing, which is not right. It's not right at all. But if you do it before this, finally log back in. Welcome back, Texan. How you doing? It has been a while. Been a while. Let's see. Cube 0, so it's still 0. Not good. File expression. That should end up with just 1 line. So right now. Whoops. Problem. It should probably be a push as well. So push 0. And let's see. You know it doesn't matter at the end, but you know. 2. No, just -1 actually. Okay. That needs to be an underscore. We need a state as well. That's the wrong one. Right, that shouldn't change anything. Wait, it did change. How did that change? It's still grabbing the wrong one though, so maybe I should walk through the GDB and see what it looks like. So let's break on generate. Run kano.kano. Yes. And we'll just walk through it. So type native, so we write it, another font. Then we go here and we have another write. And then we have the variable declaration. It should be. Yes. Okay, so let's print state stack size, which right now is 0, which that makes sense because the write syscalls end up always with 0. Then compile expression, and it should be 1. Yes, so it is 1. So we set the stack size, and it's 1. So it's at the first one. Yeah. PC still isn't fixed after like a month. You still haven't figured it out, really. Okay. Then we go here, and we append another one. So let's print state stack size is 1, and then print state stack size. The caravan is big OCaml community with a variety of streamers. Some do Rust, some do Zig, some do Elixir or Lisps. So it's an OCaml community, but they don't do just OCaml. Well, how do you join? What do you have to do? You have to sell your soul. I'm just kidding, by the way. Okay. We have another right. Okay. The main part is OCaml. Okay. That's 2. Put another one. So it's 3, so that's fine. Then we get to the exit, so this must be where it breaks. Wait, hang on. From... Actually, am I doing that wrong? Where I'm grabbing it. So if we set the 3rd position. Oh no, actually that's right. That's right. I'm doing it right. Well, yeah. So how do you? How do you join it exactly? How does that work? state stats. Such variety of people that everyone does some programming links outside of OCaml. Okay. I have no idea. I've never seen that name before, Texan. I'm not sure. I mean, I would like to do some more OCaml at some point as well. I just have not been able to so far. C/sig, I have to review C. Okay. Okay. Alright, so that made it one larger. So that should still be fine. Current stack size, that makes sense. Based on all that. But then it actually is going to decrement. Because we consume it. Oh shoot, but actually, well, CMA, yeah, I remember you talking about that. Okay, I don't think you can do that. That works. Okay, so it's 4 at the end there. I don't know, it's kind of confusing. Okay, one more in depth. Nice. And it's open. And that's it. Okay, so I'm not sure why it broke. Actually, I should have stepped into it. So let me try that. Break generate, and I'm just gonna step into it. Yes. And yeah, I'm just gonna step through it until we get to the exit call, and I'm gonna go to the compile expression. So one more declaration. And yeah, let's go to compile expression, step into that, and let's see what happens. So we have the left-hand side and the right-hand side. Let's display state stack size. We're gonna look at it each time. What? Oh yeah, so we get the variable location. So let's index to display that. Index is 1. Okay. And the stack size is 3. Oh shoot. Wait. I forgot to subtract the stack size. That's why it's not working. What the heck? Yeah, because we have to do that. I thought I did that. I did that. I guess what? Shoot, I think it's actually right now. Okay, let's try it. So time, 10. Go back. 24, is that right? Whoops, that's the wrong one. Kano. Foo, that's right. And let's try var. And that should be 27. 24. Why is it 24? Oh shit, I didn't rebuild it. Okay, let's try it again. 27. Okay. Let's get rid of this right. And see if it still works. Okay. Let's try another again. I am working on Kano script, which is the scripting language that I'm going to be using for Kano, for like, plugins, config, all that kind of stuff. I'm building it on top of an old virtual machine. Not really old, but I worked on it a couple months ago, and then I came back to it. So like it compiles to that. So it's like the Java virtual machine, if you're familiar with that. It compiles to the bytecode, and then it gets interpreted. So I'm building it on that, and then I'm going to integrate it into Kano once it's like feature complete, at least for the most part. So right now, this is what it looks like. Yes, we have write. So this just basically calls a write syscall. And it will basically output this string to the standard out. And yeah, so that's what write does. And you have exit, where you can exit with an expression, right? So something like that. Or you could have a variable in there as well, which I just implemented variables. So this is what variables look like. So you can define them, foo, colon, not foo, name, colon, data type, which right now we only have ints, and then you can set it to an expression. Yeah, that's basically all the features that we have right now. But that's what I am working on. Let's do 15 plus 2. Okay. Slash tagging, Kano.tagging, Kano.tag. Echo that, and 39. Is that right? So we have 15 plus foo, and foo is 24. So that is right. Shoot, that actually works. Okay, very cool. And we do have like precedence and all that stuff, so you have multiplication, and that actually works. So this is going to evaluate 24 times 2, so 48 plus 15. So we can look at that. Field slash time. 63. So hang on, is that right? So it was 48. Yeah, that is right. So very cool. So I'm gonna actually commit this one because I have not committed all day. Yeah, and then I probably have to about the end of the stream. So I'm just gonna make sure everything is working, and then I will let you go. But I'll commit this. So implement variable declaration and use within methods. Okay, push that. Yeah, 184. I should have committed earlier, but I forgot to. No script. Okay. Very cool, very cool. So we should be pretty good then. It seems to be working quite well. I just need to make sure I keep track of the stack size and I don't get it, out of sync. But yeah, so now we can exit with that. Can we use it in other ones though? So if we set it equal to 3, and then we exit with another, it should be equal to 24 as well. So if I run that, what's the name? Build a slash pilot, .10, echo that. 24. Okay, let's go. Very cool as that works. I need to update the git ignore though. Because I forgot to do, I thought I did, wait, what? But it was here, so I need to remove. Okay. Okay, yeah, so that is probably going to be about it. That worked out pretty well. So we got the variables. We can declare them now. Keep track of their position in the stack. And that's going to be useful for once we implement scope, right? So in if statements or other types of blocks, at the end of the scope, you want to pop all of the elements off the stack. So yeah, the next stream, unless I encounter some bugs, probably going to be working on if statements. I will lurk. Okay. Probably going to be working on if statements. So I'm thinking something like this. And I want to talk about something quickly related to this. So something like if foo equals 12, something like that. I have to add a alert command. What would it do? I'm not familiar with what that would do. But I can do that. It should not be too hard. So if that equals 12, do I want that? I probably want like a then. And we'll have an end, and n will be sort of general. So something like this, and this will be a block, right? This is what it's going to look like. Do I want the then? Yeah. But then I want to also eventually implement switch, right? So it's going to look like this. So hear me out on this. It's going to look like that. And then you'll have the case 12, right? Like that. Isn't that just Lua? Yeah, well, it's going to be a lot like Lua. But the thing is, it's lower level. Like, there's going to be pointers and things like that. Oh, okay, I see. Yeah, I can implement that. I will do that. I need, like, a reminder, though. Probably put that in the Discord. Yeah, but this is different from Lua, right? So then that. So this is like Jai, which isn't public, but this is how it works. Basically, so you can easily turn an if statement into a switch statement. I think it's pretty cool. I might not have this then, though. I don't know. I don't know if I need it. I'm going to see how the lexing goes. Because, like, if I can have it just like this, that might be cool. But I don't know, like, how are you going to know? I guess if the next token is not an expression valid token, a valid expression token. See you next stream. Yes, indeed. I will implement that command. I'm going to just send myself a Discord message, and then I will hopefully remember to do it. Okay, yeah, so it's going to look something like this. I'll work on that next time. So, thank you for watching, and I'll see you guys next time.